Hi everybody. In this video I want to talk about elastic and inelastic collisions. An example of an elastic collision is when you have one billiard ball striking another, they bounce off one another, they are back to themselves, no deformation in shape is ever occurring or anything like that. Okay, so uh, on the other hand, we have something called an inelastic collision, such as a bullet striking a lump of clay. When the bullet strikes the lump of clay, the clay that might have been stationary slightly moves in the direction that the bullet was going. So that would be the case of a perfectly inelastic collision. Okay, so what I want to do is I want to give you an inelastic collision in one dimension, followed by an inelastic collision in two dimensions. That was hard to say. So let's start off with, here we have, I'll just move this up here. Let's see. Whoops. Yeah, it's me, Joe. You can tell it's me. All right. What does it say here? It says a boy, 30 kilograms, runs off a boat dock straight into a stationary boat of mass 50 kilograms. And he was running at 5 meters per second. Assuming a perfectly inelastic collision, in other words, they stick together and the boy stays in a boat, what will be the speed of the boat and the boy? Okay, you'll notice I drew some real crude pictures here. Here's a boy, and there's the boat. That's the initial situation. In the final situation, there's the boy, there's the boat. They're one mass. That's what we're considering it as anyhow. Okay? So question is, what will be the speed of the boat and the boy? So I'm going to just, my solution's already done here, but what are we talking about? We're talking about momentum at the beginning is equal to the momentum at the end, or PI is equal to PF. Okay, so let's just throw some numbers in here. We have the mass of the boy times his speed or velocity at the start, plus the mass of the boat, which is 0, that's why I crossed it off, is equal to, now the mass of the boy and the boat are considered one mass. That's why we're going to call this M1 plus M2 in brackets. And the boy is going to be going a final velocity. We could have called it V1F. We could have called it V2F. Doesn't matter. Okay, so let's carry on with this. The mass of the boy times the boy's velocity is 30 kilograms times 10 meters per second. That's going to be the boy's momentum. And the combined mass and the final speed is going to be right over here. Okay, just working it out a little bit. We have 150 kilogram meters per second is equal to 80 kilograms times the final velocity. Carry that through, divide out that 80, you have 1.875 meters per second is the final velocity. And we would probably call that, well, I never really was talking about sig figs here, so you might end up calling that 1.88 or 1.9, depending on how the question was given to you. I promised I wasn't going to get burdened with a discussion on that sort of thing here. So this is the number your calculator will spit out. Okay, so that went a little fast, but that's okay. That's the beauty of videos. You can pause them when necessary. All right. Here we have a collision in 2 dimensions. Let's read it together. The 1,300 kilogram car going 20 meters per second east collides inelastically with a truck of mass 10,000 kilograms heading north. What will be the final speed and direction of the car/truck? And we need to put in there that the truck's initial velocity is 15.6 meters per second north. Okay, so I'm going to draw on this page. Let's see here. Let me just take care of this. Look onto the other page and see what I have. Okay, nothing yet. So here we go. What do I expect to happen? I'm going to pull this in a little closer. Well, I have a car. It's going this way. I'm going to just split the question up here. Car is going that way. The truck is going that way. There's our 2 dimensions. So we're obviously going to have to do a little bit of trigonometry here to work this out. Before we flip the page, though, let's find out what the momentum of the car is. And that would be P1. And the momentum of the car is going to be 20 times 1,300. And that's going to be 26,000 kilogram meters per second. And the truck is going to be momentum of the truck, that's P2, is going to be the mass of the truck, which is 10,000 kilograms times 15.6 meters per second. And that works out to 1.56 times 10 to the 5 kilogram meters per second. Okay, this would be 2.6 times 10 to the 4. Can you see that? Yep, you can. Okay, so we're going to have to do a vector diagram here, all right? So let's flip the page. And we're going to carry on. So here I have the car at 2.6 times 10 to the 4 kilogram meters per second. That's the car. Then we have, this is the truck. And I hear the family wants to go grocery shopping. So, okay, we're going to do that once I'm done this video. So the truck has momentum of, what did I say? 1.56 times 10 to the 5. The 5 kilogram meters per second. So the final momentum will go this way. Just some simple trig here. That's not the straightest line in the world, but We can work that out. We know this is a right triangle, and let me see what my calculator says here. If you take, and we want to find this angle here, it's we're going to call that theta. If you take this side, divide by this side, you should get 6. So I'm going to go opposite over adjacent, tan is equal to, tan theta is equal to 1.56 times 10 to the 5 over 2.6 times 10 to the 4, and that works out to 6 exactly. If you want, let's put 6.0 to make it look real. Okay, so tan inverse of 6.0 is equal to our angle of interest, and that will be 80.5 degrees. 80.5 degrees. So that will be 80.5 degrees. If you want to call that 9.5 degrees east of north, that's all good too. Okay, so this is going to be an angle of 80.5 degrees. Let's figure out what that length is together. Okay, why don't you pause the video for a second, and we'll do that. Example 5. Let's see here. 1.565 squared plus 2.64 squared equals, and the square root of that is equal to 1. Okay, that's scientific notation I want. 1.58 times 10 to the 5. 1.58 times 10 to the 5 kilogram meters per second. Actually, this is 1.58. That's 1.56, both to the times 10 to the 5. So that's very interesting. They're almost the same, almost equal. I'll put my 80.5 in there. Now, what will be the speed of that system after they collide? Can you find that? Can you determine that for yourselves? What will be the speed of the car-truck system when they collide? Well, we know the final momentum is 1.58 times 10 to the 5 kilogram meters per second. So let me ask that. What is the speed of the car-truck system? And I am going to leave, wow, that's some serious crooked writing there, but I'm going to leave that for you to determine on your own. And just a little hint, well, we know that the car-truck system, they stick together, so their masses have to be considered together. We know that the mass times the final velocity is equal to the final momentum, which is 1.58 times 10 to the 5. And it's a simple calculation. So I'm going to call it a video here, and I will see you on the next one. Thanks. Have a great day.